So, moving on, so let us now go back to the 4-stroke petrol engine and then look at the strokes themselves, right. So, we are discussing the operation of this SI engine, we looked at this diagram. Now, let us look at the 4 strokes of a 4-stroke spark ignition engine. So, let us see what happens in each of the 4 strokes. So, first let me take the suction stroke. So, what happens in a petrol engine is that when the engine starts one operating cycle, as a first stroke the piston starts to move down, okay, as we can see in this figure. So, during the suction stroke the piston starts to move down, okay, the piston is going from the top dead center towards the bottom dead center and the inlet valve is opened, okay. So, what happens is that either air or fuel air mixture is taken into the combustion chamber due to pressure difference during the suction stroke. We are going to see what are the different mechanisms of introducing this fuel air mixture, okay, in typical petrol engines when we go to what is called as mixture preparation. So, either air or fuel air mixture is taken into the combustion chamber during the suction stroke. The exhaust valve remains closed, right, because we do not want what is called as exhaust gas dilution, right. So, the camshaft becomes very critical here. It has to operate in such a way that during the intake stroke it opens only the intake or inlet valve, but it closes the exhaust valve. Why? Because if the exhaust valve were open, the exhaust gases, right, which are present in the exhaust manifold may come into the combustion chamber, right, due to the pressure difference. The pressures in the exhaust manifold is going to be higher, right, and in the combustion chamber is going to be lower during the suction stroke because volume is expanding, right, during the suction stroke. So, we do not want the exhaust gases from the previous cycle to come into the combustion chamber, and that is why we want the exhaust valve to remain closed during the intake stroke, okay. So, that becomes very critical. So, what is exhaust gas dilution? It is the process by which exhaust gases mix with fresh charge, okay. Fuel air mixture is called as a charge, right, and dilutes it, because obviously as you can see, like you mix exhaust gases, the combustion process is going to be affected, right, is it not, okay. So, the effectiveness of the combustion process will go down. So, during the suction stroke the piston moves towards the BDC, and when the piston reaches towards closer to the BDC, right, the inlet valve is closed, okay. So, the air fuel mixture or air has been taken into the chamber and the inlet valve is closed and the suction stroke ends, okay. So, just to recap, during the suction stroke the inlet valve is open, the exhaust valve is closed, and the piston moves from the top dead center to the bottom dead center, and the inlet valve is closed when the piston reaches the bottom dead center, okay. So, at the end of suction stroke we have the fuel air mixture in the combustion chamber in a spark ignition engine, okay. So, now what happens in the next stroke? So, the second stroke is the compression stroke. So, in the compression stroke we can observe that both the inlet valve and the exhaust valve remain closed. So, the piston starts to move from the bottom dead center and starts to go towards the top dead center. Okay. So, that is what happens during the compression stroke. So, what happens, the fuel air mixture is compressed. So, as a result the pressure increases and the temperature in the cylinder also increases. Okay, the pressure in the combustion chamber and the temperature in the combustion chamber both increase during the compression stroke. And during this process we will later observe that the fuel air mixture mixes well, so that like we get an almost what is called as a homogeneous mixture of fuel and air. That will promote more efficient combustion when the spark ignites the fuel air mixture. Okay. So, there is also one important aspect of the compression stroke. Okay. So, the compression stroke ends when the piston reaches closer to the top dead center. Okay. And obviously we want both the valves to be closed, right. We do not want any fuel air mixture to escape through any of the valves, and this is where the importance of compression rings is also felt, right, because we should have very good compression rings such that there is no leakage between the piston and the cylinder valve, right. So, that becomes very important. Okay. So, these are the critical attributes of the compression stroke. So, once the compression stroke is completed, towards the end of the compression stroke, the fuel air mixture is ignited by means of the spark plug. So, what happens here? So, the piston goes closer to the top dead center and the spark plug gives a high voltage spark which ignites the fuel air mixture. So, the fuel air mixture combusts, right. So, close to the top dead center the fuel air mixture is ignited and obviously combustion happens. We are going to generate lot of thermal energy, high pressure gases that are going to push the piston down. Okay. So, the pressure and temperature increase tremendously during the stroke. Okay. I am using P for pressure and T for temperature, right. So, the pressure and temperature of the fluids inside the combustion chamber increase tremendously during this expansion stroke or the power stroke, and obviously we want both valves to be closed, we do not want any leakage, and once again the importance of compression rings can be felt here, right, because we do not want any leakage once again, right. If there is a leakage, then the effective work that is done on the piston would reduce. So, we do not want that also to happen. And this is the main stroke where energy is transmitted from the fuel to the piston, and that is why it is also called as a power stroke. The term expansion stroke is very obvious because the hot gases expand, the piston moves from top dead center to bottom dead center. Power stroke because the energy to drive the other strokes is and also the vehicle is obtained during this particular stroke. Okay. So, that is the power stroke or the expansion stroke. So, let me so this is the power stroke, okay, this diagram. So, the last one is the exhaust stroke. So, when the piston reaches close to the bottom dead center towards the end of the power stroke, the exhaust valve will be open and the gases which are the products of combustion are now going to be pushed out. Okay. So, that is what will happen during the exhaust stroke. So, now you can see that the exhaust valve is open, the inlet valve remains closed, right, because we do not want the exhaust gases to pollute the next cycle's fresh charge, right. So, the exhaust valve is open and the piston moves from the bottom dead center to the top dead center and pushes out the exhaust gases, right. When the piston goes towards the top dead center, the exhaust valve is closed and the inlet valve opens and the next cycle starts. Yes, please.
So, how do you differentiate between, so there are two similar kinds of strokes, two compression strokes and two expansion strokes. How does the engine differentiate, this is the first one and this is the second one?
So, the first stroke is a suction stroke, right. Although the volume in the cylinder is expanding, energy is not transferred to the piston, okay. Energy is transferred to the piston only in the power stroke or the expansion stroke, right. In the case where in the strokes where the volume is decreased in the compression stroke and the exhaust stroke, you can see that in the compression strokes the valves are closed, whereas in the exhaust stroke the valve is open. So, what you need is the correct sequence of strokes, right. So, when you start the engine, the piston is going to be at some location and there is going to be a mechanical marking of the stroke. Yes. So, there will be like the mechanisms which are there will be sort of coded, right, with information of these strokes. When you come to the lab, you will look at all these aspects, right, the exact mechanism by which it operates.
So, for the power stroke, I could understand why temperature increases because it's an exothermic reaction, and it's expanding, the volume increases. How exactly is the pressure also increase?
Pressure increases because the volume increase is not so significant when compared to the amount of thermal energy you release. So, even if you look at the ideal gas equation of state, PV equals MRT, right, temperature increases due to the tremendous increase in the energy, right, which is thermal energy is created from the chemical energy of the fuel. So, if you keep M and R to be the same, PV is increasing. So, but the volume is increasing, but not to the extent to balance it out. So, pressure also increases. Okay.
So, how do we ensure that the pressure outside the exhaust valve is greater than inside of the combustion chamber, so that the exhaust gases flow out?
Okay, that is an important factor we will come back to when we study emissions. So, her question was, when I want to push out the exhaust gases through the exhaust manifold, through the exhaust valve into the exhaust manifold and to the what are called after treatment systems, what happens is that like I need a pressure difference, right, because the pressure there should be lower, otherwise the gases are not going to move, correct. So, how do we assure that? Ultimately, you can see that if you do not have any of those, you just have a pipe, obviously you are dumping to the atmosphere, right, and there is going to be a significant delta P which will enable that flow. But once you start adding all these elements, you are going to have what is called a significant back pressure. Then we need to start worrying about what will happen, right. So, that we will figure out, right, as we go.
Yes. So, do those strokes happen in phase in all cylinders or?
No, it will not. Okay. So, we are going to exactly the next point which I am going to discuss. So, we have looked at all these 4 strokes. The strokes do not happen in phase in all the cylinders. What do I mean by that? You will not, let us say you consider a 4-cylinder engine, the suction stroke will not happen at the same time in all the 4 cylinders and so on. They will be spread out. Okay. So, there are multiple reasons for that, because you want the power stroke to be spread out, right. So, that like you sort of get a uniform energy output on the crankshaft. And imagine another reason is that like imagine that all 4 cylinders are going through the power stroke at the same time. That is going to create lot of mechanical load on the crankshaft at the same time, right. So, that is also something which is undesirable, right.
So, does that mean that the power stroke of one cylinder will do the compression stroke of another cylinder?
Okay. So, the point is the energy obtained from the expansion stroke is essentially providing the energy for the compression, suction and the exhaust strokes. Okay, we look at that when we do the analysis. Even if you have a single cylinder engine, that is what happens, right. If you, your perspective is okay if you have a multi-cylinder engine, but I will slightly reorient it, because even if you have a single cylinder engine, the suction, compression and exhaust stroke in that single cylinder engine have to be sustained, right. Flywheel smooth on the torque, but the energy obtained from the expansion stroke sustains it. Okay, yeah. Which one? Not only that, because you obtain a lot of kinetic energy, right. That essentially ensures that it provides the energy to the other strokes. Okay, when we do thermodynamic analysis using the PV diagram, it will become clear to you. Okay, so these are the 4 strokes in a 4-stroke engine, and the power stroke or the expansion stroke provides the energy, and the other 3 strokes are what to say, take energy, like from the crankshaft, right. So we will, when we do the engine analysis, we will calculate expressions for the net energy output or the net work output from these 4 strokes. That is an analysis that we will do when we come to what are called air standard cycles analysis in a few classes. The next, before I go to the next topic of 2-stroke engines, a quick discussion on how a 4-stroke compression ignition engine works. The strokes remain the same, but the main difference is now that the spark plug is going to be replaced by a fuel injector, and during the suction stroke only air is taken into the combustion chamber in a compression ignition engine. Okay, and during the compression stroke only air is compressed, okay, no fuel, only air is compressed during the compression stroke in a diesel engine or a compression ignition engine. And towards the end of the compression stroke, when the air has been compressed to a high pressure and temperature, fuel is injected into the combustion chamber by means of fuel injectors. It is sprayed in at high pressures and the fuel self ignites, and that phenomenon leads to the power or the expansion stroke, and the exhaust stroke follows. So that is the fundamental difference between the the 4 strokes in a compression ignition engine as opposed to a spark ignition engine. Okay, so those are the main features. Okay, so let me present a brief overview of a 2-stroke engine, and then we will see how it works, right. So let me just write down what I orally told about the strokes in the compression engine. So first difference is the presence of fuel injector, right, no spark plug. The second main difference is only air is compressed, okay, not fuel air mixture, okay, and fuel which is injected towards the end of the compression stroke self ignites. Okay, so that is another important aspect in a compression ignition engine. Okay, yeah. So let me give you a brief overview of 2-stroke engines, and then we will continue the discussion in the next class. So how does a 2-stroke engine differ from a 4-stroke engine? So this is just a simple schematic of a 2-stroke engine. Of course, I am just taking a spark ignition engine once again. We can draw a similar schematic for a compression ignition engine. As we have already discussed, main difference is going to be the spark plug being replaced by the fuel injector, right. So we can immediately see some big differences. The crankshaft is still there, right, the piston and the cylinder and the connecting rod are all still around, right. We still have the spark plug, we still have the cylinder head. However, what is missing is the valve assembly, right. So no valve assembly, camshafts, right. As a result, no mechanisms for driving the camshaft, timing belts, gears and so on, right. So then how are fuel air mixtures and taken into the combustion chamber, and how are exhaust gases removed from the combustion chamber? We have what are called as the intake port or the inlet port, the exhaust port, and what is called as a transfer port. Okay. So rather than valves, in place of valves, we have intake or inlet ports and exhaust ports. Okay. So these are the mechanisms by which the fuel air mixture is taken in and exhaust gases are removed respectively. Now of course ports means they are also like some openings or channels, right. So we can we will shortly see when we discuss the operation of a two-stroke engine that the piston itself covers and uncovers the ports at the appropriate time. Okay, we are going to look at that aspect. And anyway, as the adjective two-stroke indicates, we have already discussed, right, one cycle, one operating cycle is completed in 2 strokes of the piston. So this corresponds to how many revolutions of the crankshaft? Implies 1 revolution of the crankshaft. So we can immediately see that one cycle is completed in 1 revolution of the crankshaft, whereas in a 4-stroke engine, 1 revolution is completed in, sorry, 1 cycle is completed in 2 revolutions of the crankshaft, right. That is a primary difference. Okay. And there is something called as a transfer port in a true 2-stroke engine. Okay. We look at what is the role of this transfer port, okay, in the functioning of a 2-stroke engine in the next lecture. Okay. So in the next class we will discuss some more critical aspects of the 2-stroke engine and look at its operation, right. Thank you.